So in this example, we're going to go back to the idea of the standard normal distribution that we talked about a couple of videos ago. And we're going to try and find an unknown mean in this particular case using that result. So we've been told the weights of biscuits in a box are normally distributed with a mean of mu, standard deviation of 0.5, and we know that 20% of the biscuits in the box weigh less than 5 grams. So we've been given a value and a probability, and that's going to be sufficient for us to then be able to work out this unknown mean that we've got here. So that's our goal, find the value of mu. As I've mentioned before, sketch it out on a diagram first of all so that you can see what's going on. So what we know is that we've got a mean of mu. We'll put that in the middle. We know that the probability of being less than 5 is 0.2. So given that that's a probability of only 0.2, I know that 5 has to be below the mean, because if it was above the mean, if the 5 was over here, then the probability would have to be more than 0.5. The fact that the probability is only 0.2 tells me that 5 has to be on this left-hand side. So I've already got a bit of insight. I know that the mean is going to be something greater than 5. So I'll be able to gauge whether I've got an accurate answer or not a little bit from that. If we put together the key bits of information now, as always, try and write down what the distribution is that we're dealing with. So we know that the mean is mu, the standard deviation is the standard deviation is 0.5. And we also know now the probability that x is less than 5 is equal to 0.2. So get this information and put it into the standard notation that we want to be using for any normal distribution question. Now this is where we're going to now go to our standard normal distribution, because we know that there is a value of z beneath which we would also have a probability of 0.2. And we know that then the x and the z values are connected by a formula. Z is equal to x minus mu divided by sigma. So we're going to use that formula to be able to work out what mu is equal to for this particular situation. So we go to our GDC, we can do inverse normal on 0.2, but we're doing standard normal distribution, which means the mean is 0, the standard deviation is 1. That gives us minus 0.842 to 3SF. So what we'll now do is, having found that value and stated that value, we'll put it into that formula. So the z value is equal to the x value minus the mean divided by the standard deviation. If we rearrange and solve, we'll get that mu therefore is equal to 5.42, which, as we said at the start, we were expecting to get a value that was more than 5, but not by a huge amount given the standard deviation is so small at 0.5.